Hello everyone, I'm Mayura Muralibabu
Hello everyone, my name is Moksh Shah.
and we are here to present Project 1 Cyber Attack Detection. So the problem statement. In this project, we aim to develop a predictive model for network intrusion detection. The model will be capable of distinguishing between bad connections and good connections. The methodology has 4 steps: data pre-processing, model training, analyzing the model results, adding additional features. Step 0. Here is the data set, and we can see that the data set has 49 different features. And step 1, we import the train and the test data set, and we differentiate the features into discrete, categorical, continuous, and dependent variable. Step 2, we analyze the data set and find missing values. The feature service has a missing value, and we remove the feature. Step 3 is detecting outliers. The outliers reduce accuracy and increase error. So the feature proto had outliers. So we count the number of occurrences in the feature proto, and we selected the top occurrences so that we can avoid outliers. The step 4 is we applied one-hot encoding for the categorical features. And step 5, we did correlation analysis and found highly correlating features. uh, Step 6 is we drop those correlating features, the features which are highly correlating. And seventh step is splitting the data. So X train contains all the features and Y train contains the label, which is the target feature. Step 8 is normalizing. So we do normalizing. We do the normalization process because the data set, each few particular data set features over dominate the other features. So to avoid this, we normalize the continuous and discrete features. And step 9 is data balancing. So we did data balancing using a random resampling method. So here in the SNS count plot, we can see that the data is imbalanced, and we downsampled the data set, and in this image we can see that it has been equalized. The next is model training, logistic regression. So we perform more logistic regression on the X train and Y train, and then the recall score is 0.97, and precision is 0.70. Nearest neighbor, KNN. So we performed next, we performed the nearest neighbor, and the precision score was, can you scroll down? The precision score was 0.79 and the recall is 0.91. And then we performed the support vector machine. Then the precision score is 0.53 and recall is 0.87.
So for the neural network, we use 3 dense layers, 32 layers, 16 layer, and 8 layer. And we use activation function as ReLU and optimizer as Adam. We have performed early stopping and model checkpoint. Early stopping is used to stop the epoch if the accuracy is not improving furthermore. And the model checkpoint is used to save the weight for the future use. From the neural network, we achieved 84% of accuracy. So from the model that we have trained, we did an analysis and compare the confusion matrix and ROC curve for that. So ROC curve just compared for false positive rate and true positive rate. From the comparison, we find out that neural network got the highest accuracy and SVM got the lowest because of the larger data set with the fewer features. In the neural network, we performed multiple activation and optimizers to by tuning the parameters, and we checked the accuracy that 10H activation and Adam optimizer achieved the highest accuracy of 86%. So we divided the task equally. First, we did data processing, in which we did data balancing, normalization, data preprocessing, data cleaning, and all. Then we equally divide models. Mayura performed on logistic regression and SVM, and I worked on KNN and neural network. I also tuned the parameters for the neural network. And at last, for the additional features, Mayura worked on identifying the important features, and I have implemented the multi-class classification on attack cat feature, and then we perform the neural network. So while working on the project, we came up with a lot of challenges. And one of the challenge was when we were doing normalization and one-hot encoding, we found that there is an inconsistency with the values in the field of proto. So we check the occurrence of the each value and then we remove the other values to remove the inconsistency. And these are the other challenges that we face, like data balancing to improve the accuracy, detecting the best feature for the target variables to remove the outliers, and also we tune the parameters for the neural network to get the best accuracy. So here we have also implemented the additional features in this project. We identify the important features using the correlation metrics by increasing the limit value of a correlation, and we divided the highly correlated and the less correlated features, and we dropped the highly correlated. And using those features, we performed a multi-class classification model on a neural network using activation function as a tanh and optimizer as Adam. And we get the best accuracy of 86%. Sure, we have created a balanced data set using downsampling, and that's it for our presentation. Thank you.
Thank you.